Okay, in this video I'll be going through 7A, which is the beginning of bivariate data, which is honing in on the response and explanatory variables when we're looking at bivariate data. So once again, we are starting bivariate data. So the previous topic we were looking at univariate data, which is looking at one form of data. Whereas bivariate data, we have two variables, and the aim is to see if there's a relationship between the two. So for example, I could ask, is there a relationship between a student's mark on a test and the amount of time they spend on the test? Something like that. So if I go to the next page, so we want to identify if we have two variables. We want to identify one of the variables as the explanatory variable and the other variable as the response variable. And these can be shortened to EV and RV. So obviously, a way to think about it is the explanatory variable explains and the response variable responds. That's why they have their names. Another way you could look at it is that the explanatory variable, you say, what do I change? And the response variable would be, what do I observe? So what I mean by that is you're changing something. So you might change how many hours each person studies for a test, and then you're observing the student's test result from that. Also, another way of looking at it is to think of the explanatory variable as the one that creates the change or has the power, sort of thing. You would never write that in a report or anything, but it's creating change in the other one. Whereas you would find when you're looking at it, the particular RV would never create a change the other way. So we're always moving this way where this is creating change over here. So for example, do older people sleep less? So your two variables there are, so obviously we've got age, so various people's ages, and then we're going to look at the time spent sleeping. All right. I always try and start with the EV because that's just how I find it's easier for me, but some people do it the other way. So I always think which one would create change in the other. So would time spent sleeping, so how much time you spend sleeping, would that change your age? Would that change your age? Or would your age change the time that you spend sleeping? Would that have an effect? Would how old you are have an effect on how long you are sleeping? So clearly it is going this way. So your EV is your age, your explanatory variable. So the explanatory variable, the age is explaining the change in the response variable. I am changing the age in my respondents to see if there is a relationship. And then the response variable is the time spent sleeping. All right. So however you think about it, it's always going to be such a way that one way will sort of not make sense for something to cause a change or to create a change the other way. So think of which one is going to cause a change or create a change in the other variable. So think of that as like the strong one, as the dominant one. and you're going to call that the explanatory variable, and the other one's going to be the response variable. Back in the day, this used to be the independent variable, and this was the dependent variable. If you do any sort of science, you probably refer to it as that. So that's another way to look at it as well. However, in further maths, we call them explanatory and response. We'll do one more. So we've got the life of milk in hours and the temperature of the room in degrees Celsius. Once again, EV, RV, I always start with the EV. So would the life of milk, so how many hours and a milk stays good in a carton, depict what the temperature of a room would be? Or would the temperature of the room control the life of the milk? So, for example, if you had a really cold room, would that create, a longer life of milk or compared to a really hot room? Or would it be that how long the life of milk is going to actually change the temperature? So, as you can see, obviously, the life of a milk does not change the temperature of a room, but the temperature of a room can change the life of the milk. So we'd say that this is the temperature of the room, and your RV is your life of your milk. Okay? Sometimes you'll get something that is a bit ambiguous. So, for example, can you, the relationship between wrist circumference and height? So you could measure each from their own. Just read the question because it may give you a hint like, can we predict height from wrist circumference? So that would mean that wrist circumference is your EV and your RV would be your height. All right. So sometimes it will tell you in the question. You just have to read it. But most of the time they'll ask you to tell me which one, the EV and the RV. And this is super important because especially when you get into year 12, sometimes the variables are flipped in the table. So just be careful that you sort that out first before you start your graph and everything like that. I hope that has made sense and you can have a crack at 7A.